Section 4.7, we're going to start taking a look at proofs, and more specifically in this section, we're going to look at something called flowchart proofs, which is just a way to organize your thinking. We're going to start with the following warm-up. Are the two triangles congruent? If so, how? So if you take a look at them, remember our four theorems that we can use to prove two triangles are congruent. The first one is side, side, side. Then we had side, angle, side. We had angle, side angle, and side angle, angle. If this is any one of those. So if we take a look at this right here, they have AP and PD match. We have this angle right here, and also we know vertical angles are congruent. So we have angle, side angle. So we're going to say yes, by angle, side angle, the triangles are congruent. Okay, so now we're going to take a look at flowchart proofs. Once this loads. A flowchart proof is a visual way to organize the steps of your proof. Statements go in the box with the reason for each statement below. Arrows are like saying therefore. So let's try a proof. First step in a proof, read the problem and mark what's given. So in the figure below, EC is congruent to AC. So find EC, mark that it's congruent to AC. ER is congruent to AR. The question, is angle E congruent to angle A? If so, write a flowchart proof to explain why. All right, so we have what's marked, but there's also one other thing that they have in common. It's this side RC, and they both share that. Okay, so now we have to figure out which theorem can we use to prove the triangles are congruent. It should be one of these four. And if you notice, we have side, side, side. So that's our strategy, side, side, side. In a flowchart proof, the first part is to put the given. So the first given was AR is congruent to ER. The reason why we write that is it's given. Also given was EC is congruent to AC. Again, that was given. And the last thing that we needed to show side, side, side was that RC was congruent to itself. And the reason why we know it's congruent to itself is the same segment. Okay, so we have side, side, side. We've shown that they're congruent. So now we can say, all right, triangle REC is congruent to, remember whatever way you name the triangle, you have to name the second one in corresponding order. So that'd be RAC. And the reason is side, 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 conjecture. And if the triangles are congruent, then we can answer this question. Angle E is congruent to angle A, and the reason would be CP, CTC. Corresponding parts of congruent triangles are congruent. Okay, let's try another one. Okay, so again, first step, write in what's given. So PQ is parallel to SR. Notice those arrows are already there, so we don't have to write them in. PQ is congruent to SR. Again, those are drawn in. We don't have to write that. Show that SP, this side, is congruent to QR. All right, so let's look and see if there's anything that's not marked, but we can assume is true. They share a segment. If you have parallel lines in a transversal, the alternate interior angles are congruent. So those two angles are congruent. Also, these two angles are congruent. Okay, so we have to look and see if one of the theorems works. Side, 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 angle, side, and so on. And for this one, we can look at, we have side, angle, side. We also have angle, side, angle. So we can actually choose. Let's use side, angle, side. Okay, so first this was given. Two parallel lines are congruent. What else was given? Well, PQ is congruent to SR. Was given. And because we had parallel lines, we know the alternate interior angles were congruent, so angle PQS is congruent to angle RSQ. Oops, RSQ. Let's try that again. And the reason why we knew that is that alternate interior angles are congruent. And also given is that QS is congruent to itself because it's the same segment. Okay, so we have side, angle, side. We can show that PQS is congruent to P to Q to S, so RSQ by side, angle, side. And so then SP is congruent to QR by CP, CTC. All right, a couple more proofs we'll practice. Okay, we have a kite. KE is congruent to KI, so let's mark that. Just read this time. All right, so KE is congruent to KI. Show that KT bisects the angle. We know that they share this segment right here. And also if it's a kite, then these must be equal. Okay. So first, KITE is a kite, that's given. This was also given. All right, because this is a kite, IT, that side, is congruent to ET. And the reason that's the definition of a kite. And we knew that KT is congruent to itself because it's the same segment. So in our proof we have side, side, side. We can say triangle KET is congruent to triangle KIT by side, side, side. And for this one right here, the angles must be congruent by CPCTC. And if ETK is congruent to ITK, then also angle EKI is congruent to angle ETI by CPCTC. So those are equal. And then if we know that, then actually, whoops, I wrote the wrong step here, sorry. Okay, so we have ETK is congruent to ITK. And we also know that angle EQT, is congruent to angle IKT by CPCTC. And so then angle EKI must be congruent to angle ETI. Definition of a bisector. Okay, one last proof, and then you can practice some of these on your own. So again, first step, mark what's given. We have a parallelogram, so the opposite sides are congruent and parallel. Okay, so if we have parallel lines right here, those two are parallel and so are those two. And the alternate interior angles are congruent. So this angle matches this one matches this one. They also share this side. So by angle, side, angle, the triangles are congruent. So this is given. Definition of parallel lines. There's the symbol for parallel right here. Okay, and because we have parallel lines right here, we have angles that are congruent. So angle CDB is congruent to angle ABD. Definition of parallel lines. We have the same segment, DB is congruent to DB. And also we have angle ADB is congruent to angle CBD. Definition of parallel lines. Because this is a parallelogram, not only were AB and CD parallel, AD is parallel to BC. All right, definition of a parallelogram. And actually, this should have been the reason for this one right here as well. So definition of a parallelogram for both. All right, so in our proof, we have angle, side, angle. So by angle, side, angle, the triangles are congruent. So triangle ADB is congruent to triangle CBD by angle, side, angle. And so, since they're congruent, angle A is congruent to angle C by CPCTC. So again, draw on your picture, identify which theorem you're using, and then you write it in the flowchart. So